companies run serverless GPUs on their private cloud. What I mean by that is if you want to deploy any custom or open source model from Hugging Face and you want to run it via an API that auto scales with respect to the traffic you are getting, then you can run it using Tensorfuse in just a couple of minutes, and we're going to see that. A bit about myself, I'm the founder and I spent most of my time containerizing open source model, running them on cloud. So today we'll run a Stable Diffusion 3 model. It's a text to image model. And this model is actually hosted on my AWS account via serverless API using Tensorfuse. So what you see over here is a simple front-end app that I've built. And this front-end app is interacting with the model API, which is again hosted on AWS using Tensorfuse. So I have a simple prompt here. This prompt is actually will generate an image of this specific event. We'll try to make it as better as possible. Once I click on submit, it will take 10 to 15 seconds to generate the image. What's happening is, so this is something called as AWS Node Viewer, which means that it shows me all my machine which are running on my AWS account. Right here you see g5.xlarge is the GPU machine that is currently running, which is hosting the model itself. So we have our image here. I mean, yeah, this looks good. So this is what Tensorfuse does. Now, how do we deploy this model using Tensorfuse on my AWS account is what we're gonna see now. So let me switch over to my VS Code. This is the front-end app that I've written, and the URL you see is basically the model API that we have generated using Tensorfuse. So if you want to run any model using Tensorfuse, there are two things that you need. Number one is your model inference code, and the second is the Dockerfile. Dockerfile will have all the environment which is needed to run the code. So going over the inference code is where we will be using the diffuser library from Hugging Face itself, which helps you run all the text to image models. This is where I am downloading or loading the model into the GPU, and this is where I have written the inference code. All this code is actually you can find on the Hugging Face repo for Stable Diffusion 3 model. So this is the code here. It's the same code, it's just I have wrapped it around a simple FastAPI application. Now moving on to the second part, which is our Docker file, we will be using the base image of CUDA, which will help us get access to the GPUs. Here I have installed all the transformer libraries, accelerate, diffuser library, which are needed to run the model. And I'm downloading the model weights using Hugging Face CLI download command. So this is where I'm logging into my Hugging Face hub using my token, and this is where I'm downloading the model. So you can get the model again on Hugging Face repository here. We'll be using an FP16 model because it gives better quality. And once you have the Docker file and your inference code ready, now this is where the best part comes in. You see, we will run this model on the cloud, but I haven't left my local machine. Everything I'm doing is on my Mac. So there's no context switch, it's completely serverless. I'll navigate to the directory of my project. So this is where my Docker file sits, and I'll run this command tensorkube deploy, right? Yeah, you can define the type of GPU you want to use and the number of GPUs you want to use. Let me pull that up. Once you hit enter, it will start building the Docker image. Now this Docker image in itself is around 30 gigabytes, so it will take around 20 minutes to build. But in the meantime, we can go over what's really happening in the background. So 1 second. Pull up a so what's really happening in the background is this is the complete architecture of Tensorfuse. On the left hand side, you see all the commands that I'll be running on my local machine. On the right hand side, you will see certain actions happening on my cloud account, which in this case is AWS. So first you need to install our Python package. Then you have to configure our runtime on your AWS account. What it will do is it will create a Kubernetes cluster, load balancer, and a bunch of other resources which will help you generate this API and auto scale it. Now once you have this set up, all you have to run is this command which we just did. It will open a temporary instance. It's just a computer machine on the cloud. It will build your Docker image, convert it to root file system, and push it to your EFS. EFS is basically where your deployment sits. Now once this happens, that means your deployment is live, and you can access all your deployment using this command, and it will give you a simple API. Right? Now our core innovation lies in using the EFS. If you have pulled any image from Docker registry, which is more than 15 gigabytes or 30 gigabytes, it takes around 10 to 15 minutes. But we can do it in like 1 or 2 minutes max, right? So that's where we have innovated. So now going back to my VS Code, yeah, you can see this node viewer itself. You'll see this R5.4x large machine, which is now ready, and it is currently building the Docker image. Take a lot of time, so we can't complete the build. But what I can show you right now is, we'll open another terminal, and I can list all the deployments that I have done earlier. And probably instead of running the Stable Diffusion, we'll run some other code. So you can see all my deployments are sitting here, and these are the APIs that you'll get. I'll make a simple call request to this endpoint, right? Yeah, and as soon as, sorry, I spelled it wrong. As soon as I make a request, you'll see another GPU machine, it will automatically start up. Yeah. So that's how we can help you deploy like literally any code, specifically machine learning models on your AWS account. And the best part is you don't need to have knowledge of Kubernetes, probably load balancer or Carpenter, and you don't have to leave your local environment. So it really, like the shipping speed becomes pretty quick. Like companies are using us, and they have like instead of it taking them weeks, they have deployed models in just a couple of minutes.